So this is 4.7 L'Hopital's rule. We're doing number 39. So couple of warnings for you. So be careful that you don't do this specifically in an FRQ. If you're doing a multiple choice, no big deal because you don't have to show any work. But let's find the limit of the top. Is it right or left on 39? It's from the left. Wrong direction. So we want to find the limit of the top. Tangent of pi over 2, you should know that's undefined. That's going to be infinity, positive or negative, depending on what's going on. So remember, tangent, as a side note, is sine over cosine, right? In the unit circle, pi over 2 is up top. So you're approaching from the left. What does that mean? It means you're approaching from numbers smaller than pi over 2, which is this side. You're like, hey, that's the right of pi over 2. Well, right and left only works for a number line. This is a unit circle, so you don't have a right or left. There is no right or left. So you're approaching from numbers smaller than pi over 2. As I approach here, the sine approaches 1. So the top approaches 1. The bottom, cosine approaches 0, because the cosine of pi over 2, I should know, is 0. But it's approaching from positive values. The cosine in this quadrant is positive, so you're approaching 0 from positive values, so therefore a constant over 0 in a limit approaches infinity. So that is that. Then the bottom, so you put a pi over 2 there, you get pi. Pi minus pi is 0. So it's approaching 3 over 0, which is going to be some kind of infinity. Is it positive or negative? So just to clarify, you're approaching pi over 2 from numbers smaller than pi over 2. Smaller, because you're approaching from the left. So pi over 2 times 2 is pi, but again, we're approaching from smaller than pi over 2, so it's going to be less than pi. Less than pi minus pi is going to be a negative number close to 0. So it's actually going to be negative. Okay, so if this were an FRQ, I'd expect to see both limits posted. All right. Now, here would be an issue I would have. Now, technically, you shouldn't say it equals infinity over infinity, because the top does approach infinity, the bottom does approach infinity, but it doesn't equal infinity over infinity, it's approaching. So that is something you should not write down. So L'Hopital's says, if the top and bottom are both approaching positive or negative infinity, then by L'Hopital's, you can take the derivative of the top and the bottom. And that limit will be the same as the original. The derivative of tangent is secant squared. Now the derivative of the bottom, let's do some side work for that. So the side work we're going to do is the derivative with respect to x, but I'm going to rewrite that as 2x minus pi to the negative 1 power. So I rewrote this. I moved that to the top and gave it a negative power. So this is a great time to be reviewing derivatives. So if you struggle a little bit with derivatives, practicing these things will make your derivative skills better. In fact, for the next 2 months, we have at least 2 months before the AP test. So for the next 2 months, as we review, you should be getting better and better and better at everything. And therefore your grade should be getting better and better and better. So you have nowhere to go but up now, because we're pretty much done. We have one more thing, but we're pretty much done. So the derivative of that, you bring the negative 1 in front, decrease the power by 1, times the derivative of box, because this is 3 box to the negative 1 power. It's chain rule, so we have to multiply by that. So this gets us negative 6 over 2x minus pi squared. So let me put that in here. We have a problem. This is kind of ugly. And to make it even uglier, what is secant? Because I don't like secants. I like sines and cosines. So I change secant into 1 over cosine. Now, I don't like fractions and fractions because that's ugly. But we have a rule you learn in 6th grade, I believe. When you divide two fractions, you multiply by the reciprocal. So what we're going to do is multiply by the reciprocal of this. And now, all that to say, this equals this. All right. Now let's figure out the limit of the top and the bottom. So the limit as x approaches pi over 2 from the left of 2x minus 2 squared, that's going to be 0. Because pi over, whoa, that's a pi, not a 2. I just realized. That's a pi. This is a pi. So pi over 2 times 2 is pi. Pi minus pi is 0. 0 squared is 0. Done. The bottom that cosine of pi over 2 is 0. That's going to be 0. So we have a 0 over 0 situation. Do not write equals 0 over 0. That would be bad if this were an FRQ. I'm going to emphasize this again. You learn that anything divided by 0 is undefined. By making this statement, you're saying this limit is undefined because 0 over 0 is undefined. You don't know if that's undefined. It's indeterminate. When you get a limit of 0 over 0, you're not able to determine, called indeterminate. To say equals 0 over 0, you are stating this is undefined. It is true the top is approaching 0 and the bottom's approaching 0, but they don't literally equal 0. They're approaching 0, so don't say it equals that. That will be a way to lose points. But you stated the limit of the top is 0 and the limit of the bottom is 0, so you get to apply L'Hopital's. So you are allowed to take the derivative of the top and the bottom separately, and that will be the same limit. Okay, so the derivative of the top, we're going to do chain rule. It's box squared, so it's going to be 2 box to the first times the derivative of box. And on the bottom, you're going to have negative 6 box squared. Negative 6 box squared. So you bring the 2 in front, you're going to get box to the first power times the derivative of box, which is minus sign. Woo! That's a lot of work. Now we get this. On top, we're going to get 4 times 2x minus pi all over positive 12. Positive 12, because we have negative 6 times 2 times a negative. That's going to get us 12 cos x sine x. We are getting close. But if you look at the top, that's approaching 0. And the cosine of pi over 2 is 0. We're going to have another L'Hopital's. So to apply L'Hopital's, we need to show the limit of the top and the limit of the bottom are both 0 or infinity. So we can do this. That's 0. And the limit of the bottom is 0. You need to show that work. Show that L'Hopital applies. You can't just assume it applies. You have to show that it applies. Now we take the derivative again. By L'Hopital's, I'm allowed to take the derivative of the top and bottom. The top is just going to be 8. You can distribute that. You get 8x, derivative of 8x is 8, and that's a constant, that's just 0. And then the bottom, we have a product rule. So we have cosine times sine. We leave the first alone, take the derivative of the second, plus we take the derivative of the first, which is minus sine, leave the second alone. And what do we get? The top is 8. Cosine of pi over 2 is 0. That's 0. The sine of pi over 2 is 1. So that's just 1 with the negative. So that's negative 1. So we get a negative 12 on the bottom, which reduces to negative 2/3. There is our answer. That is a beast of a question. Not hard, but very tedious.